Okay, guys, so we have a Ferris wheel here. Revenge of Ferris. I know. Okay, so if you think about riding on a Ferris wheel, first, has everyone ridden on a Ferris wheel?
Yeah.
Yes? No? I know. Maybe we need a field trip to somewhere with a Ferris wheel. That would be very entertaining. Okay, so think about if you get on and you're in this little car on the Ferris wheel. What is it called? It's not like a car. It's like a cart. Okay.
Like
So you're in that.
Carriage.
Think about as you travel around the Ferris wheel, your distance from the ground. Is it linear? No. It looks a lot like the unit circle, right? So guys, the next time you ride a Ferris wheel, you're going to be thinking about the unit circle. Okay, so we are going to write an equation that's going to model the height you are away from the ground as you ride around on a Ferris wheel. Yes, over time, okay? When you are writing these equations with application problems, it is so much easier if you use cosine. So start with cosine as your basic function. Why do you think that one's easier?
Because
Yeah, what happens right on the y-axis with cosine? The maximum, right? Yeah, so it's easy because then you know the maximum is starting when 0 happens. If that's not where the maximum occurs, it's very easy to shift that. Otherwise, with sine, you're like, well, normally my first max is at pi over 2, but I have a different period and a different shift. It's so much harder. Just do cosine and save yourself some trouble. Every year someone does sine on the test, and I'll check it to see if you do it right. Okay.
wait, someone does sign on the test and you can check it.
Well, I do check it to see if they did it right. Rarely do they do it completely right, though, because it's harder. Okay. All right. Let's think about the things that we need to know if we're going to write a cosine equation. We need to know something about the period. We need to know if there's any sort of amplitude. We need to know about the midline. What does the midline tell us? Yeah, the up or down shift. And then we need to know if there's a left or a right shift happening. Okay? Once we have all of that, we can actually write the equation of the graph. So let's look at the information they give us. So the arrow is telling us where you are. So, you know, there you are, happily sitting in your little seat. It takes 7 seconds to reach the highest point where you are 55 feet above the ground. Okay, so first let's think about that 7 seconds to get to the maximum. Remember, cosine normally has its maximum on the y-axis. It's now saying the maximum happens 7 seconds in, over here somewhere. So what does that mean? Shifted to the right 7, right? Okay. So we will be going to the right by 7. Okay. I'm going to skip over that 55 feet. We'll get back to that. It takes 22 seconds to do a complete revolution.
period.
That's the period. So the period is 22. We know that's 2 pi over b, because b is what I actually need. So what's the b value I'm going to use?
11. Pi over 11.
Pi over 11. Okay, we got there. All right. Whew. Fractions are hard. Okay. We still have this 50 and 55 to deal with. So they tell us the diameter of the Ferris wheel is 50. So that's bottom to top is 50. What does that tell us?
That's the amplitude.
Okay, is the amplitude 50?
25.
25. Amplitude's 25. It's half of that total height. Now, it doesn't make sense for a Ferris wheel to just sit on the ground, right? That's not going to work so well when your little cart's going across the ground. It's up 5, right? Okay? But where does that put your midline? It doesn't put your midline at 5. 30. So what that means is you have up 30. So let's write our equation now. So we're going to have y equals 25 cosine pi over 11 parentheses x minus 7 plus 30. Not as scary as it looked, right? Like find each little piece and then put it all together at the end, okay? Questions over any part of that? Okay, good. All right, you actually get to use your calculator to evaluate this now. So get out your calculator. There is, yeah, there's like 1 page of calculator stuff on your test. So I don't even think
How long is the test?
it's normal. I need to double check if I give you a full period or not. Might be one of those like 75-minute tests. It's challenging. Yeah. Okay, so we know, easier to see on this. Okay, this is at 55 feet, right? Because this is 5 feet and the ground is 0, right? Where's the midline? The midline is always that vertical shift. Okay. Well, and they tell you like the maximum is at 55. Okay. So, what is your height above the ground 15 seconds after it starts, 30 seconds, 2 minutes? Those are x values, right?
Yeah.
Okay. So when x is 15, I want to know what the height is. And guys, I'm going to write the answers. You can check it when you're ready. I want you to round to 2 decimal places. There's a few different ways you can do this. When it's 2 minutes, am I plugging in a 2? No, what do I plug in? 120, good.
On table, how do you plug in? How do you go to a different value?
Yeah, if you go to table set, which is second y equals, I think, or second to second one over, and then it's asking you where to start, like plug it in there, okay? You can use the table, you can just plug it in. If you're just keying in the equation, please do not do it in a bunch of different steps. Just key it in all at once. Use the fraction key, your parentheses, all of that. And guys, mode matters, okay? Are we in degrees or radians? Radians, yes. Okay.
See, that's the problem with degrees.
You're in.
For physics, I need to be degrees.
Oh. Is that what that does? What can you say real A plus BI for R2?
All right, guys, if you are not getting these answers, please raise your hand so I can help you. And I mean exactly these answers, okay?
It must have been the estimation.
So, okay, you're in race. So you have two options. You can key it into white, or you can just take it
It's really high up. So, why maximum though has to be like 40 and then you grab it.
Anybody else troubles?
No, you're in the other. Upright. And then scroll.
Otherwise, you're not.
Or you can go to second table set and then you can set your starting value.
I thought you were gonna throw it at me. Okay.
Maybe that one grounded and this one doesn't.
You're in
So it probably still has some values. For D, you just have to solve for X.
Hold on. Sorry. Just like where you're facing to max. So not the graph. Not like the makes you custom it. Okay.
200 grams of sugar.
I just didn't
I don't even drink the whole bottle.
Okay, guys, let's look at C. All right, it's asking for your initial height. Okay, you are not the last person to get on. This is you. So you are not a height of 5. So how are we going to figure out? Plug what in? Plug 0 into what? X. Yeah, we're talking about the time. So put a 0 in for X. Let's see what we get. When you're ready here. okay with 19.615? Any troubles? Okay. D, how much time has gone by when you first reach a height of 45 feet? What is 45 feet, an x or a y? A y. So you could set your equation equal to y and try to solve that algebraically, and it's kind of ugly. Or what if you just graphed in your calculator, your y1 is the equation we already have. And your y2 is 45, and then what are you going to look for here? Intersection. And make sure you find the first time you hit 45 feet, because if you're going on this Ferris wheel around and around and around, you're going to hit 45 feet over and over and over and over, okay? So, let's see what our time ends up being. I'll give you a minute to look at that. All right, guys, what'd you get? Yes. Should you be labeling seconds, feet, all of that stuff? Yes. Please do. Okay. And then the last part here, part E, it's asking you when you hit that 45 feet for a second time. So you're going to hit it on your way up, and then you're going to hit it again on your way back down, okay? Yeah, because you could just add 22, but that's going to take you all the way around. That's not the second time you'd be at 45 feet, okay? I'll write it up here so you can check when you're ready. Okay, if you are struggling finding these intersections, let me know. Okay. Guys, when you're doing this, I'm not saying you should trace until you're close and tell me it's about this. I want you to actually calculate the intersection. Okay. Oh, it's so small. So let me change it. Like the Y value, it goes all the way. Okay, troubles? Okay, all right. Yeah, okay.
Intersects, and then you just really have to say like first second,
Zoom out. Zoom out. 30's gonna be out. I'm gonna turn off your stat plot. Is that okay? I don't really want to see it. Okay, so if I go second, alright, well, I just want to make sure that
Like the way I did it.
There is no.
So I was like, I just made the yeah.
yeah. Yeah.
That wouldn't work.
You're actually, well, you can tell that
You have to cancel.
yeah.
So I was.
You're right.
I love that.
That exists. You use the helping verb to
Okay, guys, anybody need more time on this? Good? Okay. All right, guys, turn the page. We are water wheeling and dealing now. Water wheeling and dealing. Sounds exciting. It might sound more exciting than it actually is. Okay, guys, very similar idea here. I want you guys to write the equation. Do part A for me. There you go.
It's got a lot. It's got a lot. You know what water
Yes.
Doesn't matter which way the rules go.
Yes. Because if you think about it, sitting this way, it's going to take a lot longer to hit 0. So think about a cosine graph. Like, it goes to that maximum first, and then it starts coming back down. So this is like plain old cosine. Figure out how long it takes to get to the middle. Okay.
So then it's the shift plus 2.
Okay, which way are we going?
Well, it's going this
There
way.
is no basis.
So you start it, 2 seconds later it's at its... So if you're on the cosine graph, normally the maximum would be here, right? Well, we're saying 2 seconds later you're at the max. Do you see it?
Isn't the greatest thing Tom for a cosine?
All right, guys, let's go through a few things. What is the period of this?
10 seconds.
10 seconds. How do we know that? Math. Yes. 6 revolutions in a minute, right? 60 seconds in a minute. So how long to do one? 10 seconds. So if that's 2 pi over b, what do we know that b has to equal then? Pi over 5. All right. Amplitude. 7. Yes, that was given to you guys. If your radius here is 7, from the center to the top would also be 7, right? Okay. Let's see. What about where is my midline? 6. So what does that mean? What? Yes, up 6 at the end, right? Okay, and then it says it takes 2 seconds to get to the maximum. So what does that mean? Right 2. Okay, so your equation would be y equals 7 cosine pi over 5 times x minus 2 plus 6. Yes? Are we doing well? Yay! Word problems aren't so scary, right? Okay. It just went really poorly. gosh, she just got like stuck in that unit for months. Oh, that sounds painful. Alright.
No one understood it.
Alright guys, so try B, C, and D for me. Guys, when you're ready, you can check up here, and if you're having any issues getting these, let me know. How are we doing, guys? Okay. I will wait. How did I get D for X? Yeah.
Oh, I see.
C. So, what is the height if we're on the surface of the water? Yes. So, this is where you graph your original equation and 0 and look where they intersect. Yep. See? So if you're on the surface of the water, what is the height?
6.
So let's look back at our picture. Alright, so like, that's 13, right? That looks nothing like a 13. That's a 6. What is the surface of the water if this is -1? 0. So when your height is 0. So like when y is 0, so you're going to want two equations, find where they intersect, or just calculate the x-intercept if you want to. Yeah. It is in feet. So what else, guys? Anything? Okay, guys. That is the end of your notes for today. I know we're not going to do that very last one.
Water in Arkansas.
It's not dealing with water in Arkansas right now. Alright guys, on your homework, there is one typo. Let me tell you what it is. All right, guys, on the homework. First, you notice the homework's just the front of the page. That's it. Okay? In the chart, everybody pay attention because it's a pain to do if you don't fix it. Where it says 4:45 a.m., it should say 4:25 a.m. Okay? And then just this page is your homework. All right? Bad. Okay, so feel free to start on it. You have now learned all of Unit 3. I don't know if that's good or